Good morning, my dear students. My name is Neer Rayana. I'm currently available at the Hamlet Tuition Center, Brahmatal, Kathmandu, and the Kumudini Kunja Secondary School, Kalimati, Kathmandu. My dear students of grade 10, this is your science class, and we were discussing on the lesson electricity and magnetism. In our last class, we discussed about heating effect of electricity, and in today's class we will be discussing about lighting effect of electricity. Well, just like heating effect means conversion of electrical energy into heat energy, just like that, lighting effect means conversion of electrical energy into light energy. Okay, when current electricity is passed through certain electrical devices, then that electrical energy is converted into light energy, and this effect is called lighting effect. And some of the examples of the devices that shows lighting effect are here illustrated here. Okay, this one is an electrical bulb. Yes, this one is an electrical bulb which is outdated nowadays. Okay, nowadays it is not in much common use, but it was the standard source of light in past. Yes, not very much long time, but around 20 to 30 years ago also, most of the people in Nepal, they used electrical bulb like this. Okay, even today many decorative lights which we use in Tihar are this type of bulb. We call them 0-watt lamp. Do you remember or not? Actually they are not 0-watt, they consume 15 watt of electricity, and yet we call them 0-watt bulb. Okay, anyway, this is electric bulb. Okay, and this one works in the principle of incandescence. Incandescence means emission of heat because of temperature. Okay, as its temperature rises, it starts to emit heat, and it does not emit light until its temperature rises or reaches as much as 2500 degrees Celsius, 2500 degrees Celsius. Only then it emits light. Okay, so this type of bulb, they are very hot as well. You just lit this bulb for 10 minutes, you cannot touch it, you cannot hold it in your hand, that much hot it will become. Okay, and next source of light, or next device that converts electrical energy into light energy, or that shows lighting effect, are these type of bulbs. Yes, these are also called tube lights, actually, because they are made up of a tube. They looks like a tube and they emit light. That's why they are called tube light. Actually they are fluorescent light. Okay, they contain fluorescent powder. Do you know what is fluorescence? Okay, we will discuss about that. Okay, our next one is also called CFL. CFL stands for compact fluorescent light. Well, I promised you that we will discuss about fluorescence in a moment. Okay, CFL stands for compact fluorescent light. Well, principally CFL and fluorescent lamp or tube light, they work on the same principle of fluorescence. Okay, both of them are same, but only one difference is their structure. Okay, this one is straight and this one is coiled. Yes, and because of coiled structure, it has higher efficiency as well. Very simple innovation, isn't it? And next one, well, you can see this is an image of a television. Yes, the television screen, and television screen are mostly made up of liquid crystal display or LCD. Nowadays television screens are made up of LED as well. Okay, but not very long time ago, television screen, the monitor, computer monitor, laptop screens, they were made from liquid crystal display, and LCD consumes even smaller amount of power. It is because of LCD that construction of laptop and construction of Android phones or smartphones became possible. okay, because they are operated by battery, okay, and battery can support LCD, as LCD draw very less amount of electricity, okay. If CRT is used to make laptop or to make your mobile screen, then well, don't expect to run them on battery, okay, that's not possible, okay. So to run CRT in inverter is also very much power consuming, that is also not suggested, yes. However, LCD consumes very small amount of electricity, it has very high efficiency, okay. And next one is LED, or light emitting diode. Well, LEDs are LED actually is not a new invention. It is not a new invention. It was discovered around more than 100 years ago. However, its use, its application has been amplified in recent days. Okay, in past, LEDs were used only as indicator lights. They were used only as indicator light. You might have seen this kind of light in many of your devices, like your bolt guard, your remote controller, okay, and battery charger, and many devices. They are used only as indicator. But nowadays the technology has been expanded so as to construct computer monitors, okay, television screens, and laptop screen, your Android phone screen, and many more, okay. And LEDs they consume even less electricity than LCD. LEDs consume even less electricity than LCD, okay. Anyway, well, all these devices that we discussed just now, these are the devices that show lighting effect. What are they? Electric bulb, yes, fluorescent lamp or tube light, compact fluorescent lamp or CFL, liquid crystal display or LCD, and light emitting diode or LED, okay. These are some devices that show lighting effect. Understood? Okay, then let's go to next slide, fluorescent lamp. Let us discuss in detail about fluorescent lamp, okay. No fluorescent lamp, it's filament lamp, okay. You know, filament means long thread, okay. Filament means long thread. A thread is called filament, and since this lamp they contain a long thread, they are called filament lamp, okay. If you see their structure, what you can see is they are enclosed in a glass vessel, yes, that is also known as bulb. This entire structure, this structure of glass, it is known as bulb. And inside the bulb you can see there are two electrodes, yes, one plus and minus, there are two electrodes, okay. These two electrodes are supported by this solid glass structure, okay, and these electrodes are connected to one of the electrode is connected to metal of base, okay, this base, and another electrode is connected to the bottom, okay. So the bottom act as positive terminal and the base metal act as negative terminal, okay. So here if you connect plus point to here and minus point to here, the circuit will be completed through the filament, okay. And these are just the supporting structure, okay. They do not make up any circuit, okay. They are simply attached to glass base and they are not connected to anywhere else, they are just supporting structure, okay. Now here you can see this is filament, and you can see the filament is made from coil, okay, delicate coil, and filament is made very thin, okay. So here to construct filament I gave you two hints, isn't it? While constructing filament I have already given you two hints. One is very, or you can say ultra thin, okay, filament, and second one is highly coiled structure, okay. So if the filament is highly coiled, then it must be very long, isn't it? If the filament is highly coiled, then it must be very long, and it is made ultra thin. Why these 3 points are kept in mind while making filaments? Well, we have also discussed in grade 9 that resistance is directly proportional. Okay, resistance is directly proportional to L, or length, isn't it? So by increasing length of wire, you can increase resistance. Yes, and next, resistance is also proportional to 1 upon thickness. Okay, the font is changed. Okay, anyway, let me do this. What's happening? Okay, Control C. Okay, resistance is inversely proportional to thickness. Okay, that means if thickness of wire increases, then resistance decreases. So to increase resistance, what you have to do? You have to decrease thickness. Okay, for this reason, the filament is made ultra thin, and for this reason, the filament, very long filament, is used, which is highly coiled. Okay, which is highly coiled. Any confusion? Okay, moreover, the coiling structure itself also increases resistivity, and by increasing resistance, what are you doing by increasing resistance? What do you get by increasing resistance? Okay, high resistance produces high temperature, isn't it? We discussed it in our yesterday's class as well. Okay, a conductor produces heat energy because of resistance. Okay, high resistance produces high temperature, and when its temperature becomes more than 2500 degrees Celsius, okay, when the temperature becomes more than 2500 degrees Celsius, then the filament starts to emit light. Okay, understood? Well, when temperature becomes greater than 2500 degrees Celsius, then the filament starts to emit light. Understood or not? This is the basic principle of how a filament lamp produces light energy. Okay, we know resistance is proportional to length and resistance is inversely proportional to thickness. So by using ultra thin and extra long filament in highly coiled structure, we increase resistance. Okay, in 3 ways. In 3 ways we can increase resistance of the coil, or resistance of the filament. Okay, so high resistance produces high temperature, and when temperature becomes more than 2500 degrees Celsius, then the filament starts to emit light. Understood? That is how the filament lamp produces light. Okay, now as a filament, what element is used? Okay, to use as filament, you must to make a filament, you must use an element whose temperature can rise as much as 2500 degrees Celsius. Okay, you must use an element whose temperature can be raised to as much as 2500 degrees Celsius. That means the filament must have very high resistance. Okay, the filament must have very high resistance. This is an important point. Yes, you must choose a material which have very high resistance. Not just that, you must choose a material which do not melt at near around 2500 degrees Celsius. If you choose a material which have very high resistance and which can get temperature, this much temperature, but they melt at somewhat, let's say 1800 degrees Celsius or 2000 degrees Celsius, then will it be useful? No, it will melt down before it can emit light. Okay, so you must choose a material whose temperature, whose melting point is more than 2500 degrees Celsius. Understood or not? You must choose a material which have very high resistance, okay, to make filament, and you must choose a material whose melting point is greater than 2500 degrees Celsius, okay, and such material is tungsten. Okay, tungsten is such material. That is why tungsten is used as filament in filament lamp. Understood? Okay, let's see what else is here. Okay, see, filament lamp, it is a device which converts electrical energy into light energy by incandescence process. Okay, this word is new to you, and this word is hard to you as well. I know this. Yes, did I say right? Okay, this word is new to you, and this word is hard to you as well. I know that. Okay, anyway, and although I cannot help it, but you have to get it. Okay, there is no other way. You have to get it. Okay. Okay, filament lamp is a device which converts electrical energy into light energy by incandescence process, which means it emits light energy in response to temperature. Higher the temperature, more light energy. Lower the temperature, less light energy. So it has to generate high temperature to produce light. Hence, it has very low efficiency at 10 degrees Celsius. Okay, so because it cannot produce light energy without producing heat energy, it has to spend as much as 90% of electricity to generate heat energy. Okay, it has to spend as much as 90% of electricity to produce heat energy, and then only 10% of electricity is converted to light energy. Okay, so its efficiency is 10%, because we are using this bulb as the source of light, isn't it? So efficiency means what percentage of electricity is being used to generate light energy. It producing heat energy is not important to us. That is not a matter for our consideration. Okay, for our consideration, we only take the amount of heat energy being generated by this bulb. Any confusion? Okay, so next point, it has low shelf life, which is about 1000 hours in average. Its shelf life is about 1000 hours. That means nothing lasts forever. Nothing lasts forever in the universe. Everything is destructible. Even the stars are destructible. Then what is this? This is also filament, isn't it? It has shelf life of 1000 hours. That is also in average. It's not exact point. Okay. Okay. Next, look here. Filament lamp is filled with nitrogen or argon. Well. Here is an important point. I told you that this is a bulb made up of glass. Yes, this is a bulb made up of glass, and inside it a filament is kept. And what is filled inside the bulb? Is it normal air? If it was normal air, then why is it necessary that we need to cover it with a glass bulb if it is simply air? But you should know that it is not air inside the bulb. Okay, it is not air. It is either nitrogen or argon. Okay, you should know that the filament is highly reactive to oxygen. Okay, the filament or the tungsten is highly reactive to oxygen. Okay, if you simply fill up air in this bulb, or if you do not put this bulb at all, if we keep it open, then as soon as its temperature rises, it will react with oxygen and form tungsten oxide, which is in powder form. Powder form means it will break and circuit will be broken and it will not work anymore. Understood? And that process is known as melting of tungsten. Melting of tungsten. Okay, so prevent that reaction, we must fill the bulb with what? Nitrogen or argon, because nitrogen and argon do not react with tungsten. nitrogen is a noble gas, okay, argon is an inert gas. Both of them do not react with tungsten. Okay, that's why an electric bulb is filled with either nitrogen or argon. Okay, look here, a filament lamp is filled with nitrogen or argon because tungsten used in filament lamp reacts with oxygen and corrodes. Corrodes means it forms oxide and it becomes powder form, tungsten oxide, which is in powder form. So to prevent tungsten from oxidation, it is filled with nitrogen or argon, which are inert or noble gas. Okay. Now tungsten is suitable for making filament because it has very high melting point at 3400 degrees Celsius. Okay, once again come back to this point. Okay, what we said that temperature of filament rises as much as 2500 degrees Celsius. Okay, so the filament must have melting point above this. So is it true or not? See, tungsten has melting point of 3400 degrees Celsius. That definitely is above 2500 degrees Celsius. Okay, and next property of tungsten is it has very high resistivity. That means it can produce very high temperature, and its temperature reaches very high up to 2900 degrees Celsius when current is passed. So light starts to emit when its temperature reaches 2500 degrees Celsius, and its temperature can rise up to 2900 degrees Celsius. Okay, that's why tungsten became suitable for suitable to be used as filament. Any confusion? This much is about filament lamp. Okay, let's go to fluorescent lamp then. Fluorescent lamp is also known as tube light. Okay, tube light. Well, it acts as by the process of fluorescence. Fluorescence. The word fluorescence, we have used this word several times today, yes, but I'm sure you are confused with this word. What is this word? Well, let me draw a model of atom first. Okay, give me a few minutes. Okay, let's resume. This is a model of an atom. Okay, when you pass ultraviolet light rays, okay, when you pass ultraviolet light rays to to this atom, okay, I need to put okay, so this sign represents what? Ultraviolet light, UV, ultraviolet ray, okay, which is also known as UV ray. Okay, what happens? What happens? Suppose this UV ray is absorbed by this electron. Okay, in that case the electron becomes excited. Yes, in that case the electron becomes excited, and out of the excitation, okay, because it has gained more energy, out of the excitation what it does, धेरै कसैको फोर्स पायो भने के हुन्छ, चुलबुल हुन्छ नि, पावर बढ्छ नि. ओके, यो इलेक्ट्रोनको पनि पावर बढ्छ है. इट जम्प्स टु हायर energy state. Understood what's happening here? यहाँ के भइरहेको छ बुझेको बुझेनौ? हेर त, यो इलेक्ट्रोन कहाँ थियो त? यहाँ थियो, तर यसले जब अल्ट्राभायोलेट रे यसले एब्जर्ब गर्छ, एब्जर्ब गरेपछि यसको एनर्जी बढ्यो नि, हैन? यसको एनर्जी बढेपछि अब यो यही अर्बिटमा बसिरहन सक्छ त? सक्दैन, किनभने यो अर्बिटमा जति एनर्जी चाहिन्छ त्यो भन्दा धेरै एनर्जी योसँग छ भने यो इलेक्ट्रोन यो अर्बिटमा बस्न सक्दैन है. तिम्रो खल्तीमा 1 लाख रुपैयाँ छ, तिमी बसमा ट्राभल गर्छौ? गर्दैनौ, तिमी ट्याक्सीमा जान्छौ. या तिमीसँग करोड रुपैयाँ छ भने तिमी प्लेनमा हिँड्छौ होला, हैन? एनीवे, त्यसै भने जस्तै यो इलेक्ट्रोनसँग पनि when it absorbs much amount of energy, when its energy level increases, it does not stay in its original orbit, it jumps up to higher orbit. It jumps up to higher orbit. Okay, तर यो इलेक्ट्रोनले पनि यो हायर अर्बिटमा पनि रहिरहन सक्दैन. यसले जुन एनर्जी गेन गरेको हुन्छ नि, त्यो एनर्जी टेम्पोररी हुन्छ टेम्पोररी कुन सेन्समा हुन्छ भने यो एटमले आफ्नो यो भित्रको अर्बिट फुलफिल नगरिकन बाहिरको अर्बिटमा इलेक्ट्रोन राख्न खोज्छ होला त नो नेभर we studied about octet rule in chemistry isn't it this atom would not tend to keep an electron in outermost orbit when the inner orbit is not in octet state or duplet state okay that's why it is not possible for the atom calls this electron back to its original orbit but to come back to its original orbit what it has to do it has to release the energy it absorbed previously okay it has to release the energy that it absorbed previously understood बुझेन हेर त के भइरहेको छ भने अल्ट्रा भायोलेट रे यसले एब्जर्ब गर्यो हो एब्जर्ब गरेपछि यसको एनर्जी लेभल बढ्यो एनर्जी लेभल बढेपछि हायर अर्बिटमा गयो हैन तर एटमको केसमा के हुन्छ इनर अर्बिट इनकम्प्लिट छ भने उसले आउटर अर्बिटमा इलेक्ट्रोन राख्न खोज्दैन त्यो अनस्टेबल हुन्छ त्यसैले यो एटमले यो इलेक्ट्रोनलाई इनर अर्बिटमा नै फेरि बोलाउँछ तर जब यो इनर अर्बिटमा आउँछ यसले एब्जर्ब गरेको एनर्जी त यसलाई युजलेस भयो हैन द्याट इज अननेसेसरी हो त्यो एनर्जी यसले रिलिज गर्छ तर रिलिज गर्दाखेरि यसले अल्ट्रा भायोलेट रे नै रिलिज गर्दैन यसले के रिलिज गर्छ त डिपेन्डिङ अन डिफरेन्ट एलिमेन्ट्स है सबै एलिमेन्टले एउटै रेन्जमा रिलिज गर्दैन तर सर्टेन एलिमेन्टले चाहिँ भिजिबल लाइट रे रिलिज गर्छ ओके कतिपय एलिमेन्ट्सहरूले इन्फ्रारेड रे रिलिज गर्छन् है धेरै जसो एलिमेन्टले इन्फ्रारेड रे रिलिज गर्छ ओके धेरै जसो एलिमेन्टले यसरी रे फ्याक्दाखेरि इन्फ्रारेड रे रिलिज गर्छ त्यो भनेको हिट एनर्जी हो ओके एकदमै थोरै मात्र एलिमेन्टहरू छन् जसले चाहिँ भिजिबल लाइट रे रिलिज गर्छ हो यो भिजिबल लाइट रे अल्ट्रा भायोलेट रे एब्जर्ब गरेर भिजिबल लाइट रे रिलिज गर्ने जुन प्रोसेस छ हो यो प्रोसेस नै के हो त फ्लोरोसेन्स हो गणित भन्दाखेरि गणित भने जस्तो सुनिन्छ है हामी स्कुल पढ्दाखेरि हामीले नेपालीमा पढेको थियौँ क्या नेपालीमा म्याथमेटिक्सलाई गणित भन्छ क्या गणित पनि होइन गणित भन्छ है अनि अहिले पनि गणित भन्दाखेरि गणित भने जस्तै सुनिन्छ ओके एनीवे आई होप यु अन्डरस्ट्यान्ड द कन्सेप्ट अफ fluorescence yes okay this same principle is used in making of fluorescent lamp okay it is a device that converts electrical energy into light energy by fluorescence process some elements absorb UV rays and re-emit the energy in the visible range such process is called fluorescence an example of fluorescent material is phosphor is salt of phosphorus okay phosphorus भन्ने एलिमेन्टको नाम त सुनेको छ नि हैन यसको नम्बर कति हो 15 होला एटमिक नम्बर 15 मा के छ फोस्फरस छ अनि फोस्फरसले बनेको सल्ट भनेको फोस्फोर हो ओके फोस्फोर शोज दिस प्रपर्टी है ल अब यो फ्लोरोसेन्ट ल्याम्पको स्ट्रक्चर एकचोटि हेरौँ त फ्लोरोसेन्ट ल्याम्पमा के छ इट इज मेड अप अफ अ लङ ग्लास ट्यूब on the both side of tube it has electrodes yes on the both side of tube it has electrodes and see each electrode coil are separate yes they have nothing in between them they are not connected so the connection is not completed through here the circuit is not completed through here okay the circuit is completed like from this electrode to the choke yes from choke then to starter then from starter to this electrode yes and then it comes like this and this electrode is connected to your AC supply okay then comes here okay in this way the electric circuit is completed like this look at the cursor of my mouse electric circuit will be completed like this in the shape of 8 understood okay now between this electrode coil the glass tube is filled with argon or krypton atoms at very low pressure okay it also has liquid mercury which vaporizes okay while the tube light is operating the liquid mercury vaporizes and it becomes mercury vapor which also fills the tube Okay, and the wall of tube has phosphor coating. The wall of tube has phosphor coating. Okay, then what happens when the electricity passes through the electrode coil? When electricity passes through the electrode coil, these electrode coils, they release electrons. They release electrons, and the electrons pass through mercury vapor. The mercury vapor acts as a vehicle for electron. Okay, with the help of mercury vapor, atoms of mercury, the electrons pass through this electrode to this electrode. Okay, and when the mercury vapor slides through glass, through the argon and krypton atoms, in that process it produces a lot of UV rays. Okay, when mercury vapor slides through the krypton and argon gas, it produces a lot of UV rays. These UV rays are absorbed by phosphor coating, and the phosphor coating releases visible light. Got it? Okay, so that's how a fluorescent lamp works. And finally the electrons will reach this end. Understood? Now that is the reason that if you use low quality of fluorescent lamp tube light, which has even a small leakage in phosphor coating, then UV rays will come out of the fluorescent lamp, and that UV rays will make your skin go darker. Okay, okay, so ट्युब लाइटको लाइट सेतो हुन्छ, चम्किलो हुन्छ है, तर डिफेक्टिभ ट्युब लाइट पर्यो भने त्यो ट्युब लाइट मुनि बस्ने मान्छे चाहिँ कालो भएर जान्छ है। इन्ट्रेस्टिङ छ कि छैन त्यो फ्याक्ट हेर। ट्युब लाइटको लाइट सेतो हुन्छ, चम्किलो हुन्छ, अनि हाम्रो दिमागमा के लाग्छ त ट्युब लाइटको लाइटमा बस्ने मान्छे चाहिँ गोरो हुन्छ, ट्युब लाइटले हामीलाई गोरो बनाउँछ भन्ने लाग्छ है। तर यसमा कतै सानो मात्रै डिफेक्ट रहेछ, फोस्फोर कोटिङ कतै सानो मात्रै स्क्रैच भयो भने भित्रबाट है, फेरि बाहिरबाट हैन, त्यो स्क्रैच भयो भने त्यो स्क्रैचबाट युभी रेज बाहिर आउने भयो हैन। अनि त्यो बाहिर आएको युभी रेजले गर्दाखेरि हाम्रो स्किनमा मेलानिनहरु बन्न थाल्छन्, र त्यो मेलानिनले गर्दाखेरि हाम्रो स्किन चाहिँ डार्क भएर जान्छ, कालो भएर जान्छ। बुझ्यौ? ओके, एनीवे ट्युब लाइटले कसरी काम गर्छ बुझ्यो कि बुझेनौ त? यसको स्ट्रक्चर बुझ्यो, यसको वर्किङ मेकानिजम बुझ्यो है। ल अब वर्किङ मेकानिजम, सरी यो माथिको नोट त लिइसक्यो है। ओके, अब वर्किङ मेकानिजमको नोट लिऊ त। Fluorescent lamp consists of a long cylindrical tube coated with fluorescent powder. It has 2 electrodes at the ends and is filled with mercury vapor. 2 electrodes are connected to choke and starter. When electricity is passed through the electrodes, electrons are freed from one electrode and flows toward another electrode through mercury vapor. मैले जे भनेको त्यही नै छ कि छैन त? When mercury vapor collides with electron, it releases UV rays that strike the fluorescent powder. The electrons of fluorescent powder absorb UV ray and emit visible light rays. Okay, this much. Any confusion? Okay, now efficiency of fluorescent lamp. Efficiency of fluorescent lamp is around 30% according to your textbook. Okay, according to the syllabus prescribed by Central Curriculum Development Center. Okay, CDC, Curriculum Development Center. Okay, it is 30%, which means it converts 30% of electrical energy into light energy, and 70% of electrical energy is converted to heat energy. So it is 3 times more effective than filament lamp. Remember, the efficiency of filament lamp is only 10%. Fluorescent lamp is 30%. That means it emits, fluorescent lamp emits 3 times more light energy than a filament lamp. That is why if you need 100 watt of electric bulb, the filament lamp in your room, then the same room can be illuminated by only 40 watt of tube light. Okay, we say 40 watt, but actually it is 36 to 38 watt. Okay, the tube light is actually 36 to 38 watt, but in general we say it is of 40 watt, isn't it? Almost 3 times. Yes. Okay, you know compact fluorescent lamp or CFL? CFL has even more efficiency according to your textbook. Once again I am saying according to your textbook, it is 90%. That means about 90% of electrical energy is converted into light energy, whereas only 10% of electrical energy is converted into heat energy. Okay, what increases efficiency of compact fluorescent lamp? It is very simple. We said that the mercury vapor has to travel through the tube, isn't it? So in case of compact light, the mercury vapor, when it travels through this coiled tube, it has more possibility of striking the phosphor itself. Okay, and that reduces the friction between mercury vapor and other inert gases in the tube in the process of transportation. Okay, that increases efficiency of CFL. Okay, so once again, according to your syllabus, according to your book, I said efficiency of filament lamp is 10%, fluorescent lamp is 30%, and CFL is 90%. But here I have small objection. In this case, I have an objection. My objection is, according to the actual documents that I have searched through internet. Okay, according to the actual document, efficiency of filament lamp is only 2.5 to 5%. It is very less, isn't it? 2.5 to 5%. But according to our book, it is 10%. Yes, but as I went through the international papers, I found it to be 2.5 to 5%, and that of fluorescent lamp is 10%. We just discussed it to be 30%, yes, but actually it is only 10%. And efficiency of CFL is 25 to 35% only, but we discussed that to be 90%. It was mentioned in the book. Okay, and efficiency of LED is around 90%. 90% is actually the efficiency of LED, but we are misled in this information. Well, that I hope that will be corrected in our syllabus or in our course of study. Okay, let's go to next topic, the last topic for today, LED or light emitting diode. We only need a short introduction about this. Okay, LED stands for light emitting diode. Yes, and diode is a semiconductor. You know what is semiconductor? The substance which conducts electricity only at certain condition, like very high temperature. Okay, and when that condition is not met, it is not a conductor, it becomes non-conductor. Yes, that's why diode is a semiconductor. In some condition it acts as conductor, in some condition it acts as non-conductor or insulator. Okay, diode is a semiconductor that works on the principle of electroluminescence. Electroluminescence means whenever electron flows through it, it produces light. Not because of friction, not because of temperature, and not because of fluorescent effect, fluorescence. Simply because electrons are passing through it at low pressure, it releases energy. That process is known as electroluminescence. Once again, this process is, this term is new to you. Yes, electroluminescence, this term is new to you. Any confusion up here? Okay, so you discuss about 3 new terms. Yes, first of all, what was it? Incandescence, incandescence, and then fluorescence. Okay, I feel that I must highlight it as well. Okay, incandescence, fluorescence, and electroluminescence. Okay, these 3 processes. Yes, filament lamp, incandescence, fluorescent lamp and CFL, tube light and CFL, fluorescence, LED, electroluminescence. Don't forget. Okay, that is, it emits light energy. It emits light energy in response to flow of electrons. Since it does not have to generate high temperature to emit light as an incandescent source, it has very high efficiency at 90 degree. Okay, 90 degree, see, whereas incandescent light source has efficiency below 10%. I have written below 10%. I do not prefer to write exactly 10%, that because I just told you about my objection. Yes, an incandescent lamp or filament lamp, it is only 2.5 to 5%. So I would write below 10%. Okay, now in SE or in board exam, what you should write, you might get confused. Yes, isn't it? Yes, that's the problem. Okay, in board exam, the teachers usually check the answer by using answer key, and answer key always matches its answers to your textbook, government textbook. That's why you should write the data given in government textbook. I hope it will be corrected very soon. Okay, next one is application of LED. You have seen LED in many devices, like it is used as headlight in automobiles. In old vehicles, filament lamp is used as headlight. That's why battery does not last very long in old vehicles. But nowadays in new vehicles, the headlights are made by using LED. That's why they are very bright. LED headlights are very bright, and they do not drain too much power from battery. Battery is also long lasting. Okay, in a vehicle which use LED headlight. Okay, as it produces high power with small amount of electricity, so it drains battery less. It drains battery less. यो कस्तो battery नभए नि हुने जस्तो पो सुन्यो है ल यसो it drains less battery चाहिँ लेखौँला it drains less battery. Okay, second, it is used in remote controllers. हेर remote controller मा यस्तो यो indicator bulb हुन्छ नि, नोटिस गरेको छौ कि छैनौ? यसो indicator bulb है हो, यो के हो त? यो पनि LED हो है, LED. अनि त्यसै अर्को हेर solar panel. The solar panel cannot generate too much electricity, isn't it? So if you use fluorescent lamp along with solar panel, then most of the energy will be wasted. Only small amount of light will be produced. However, LED can be used with much efficiency. Okay, so even with solar panel, LED can generate very high amount of light energy. Yes, and then the flash of camera. If you have used a DSLR camera, then you should know about this, isn't it? Okay, in case of DSLR camera, you might need extra source of flashlight. In that case, you use a flashlight like this, and the flashlight also has LED lamps. If the flashlight is constructed by using electric bulb, then the battery will be drained too quickly, very quickly. However, by using LED, the battery lasts longer. Plus, it gives more light. For flash, you need very high luminescence, isn't it? Okay, the next one, this you might have seen in the marketplaces. Okay, nowadays such LED message display boards are also used for advertising purpose. It also consumes very less amount of energy, so that you can turn it on, you can keep it turned on for 24 hours a day without consuming much power. Okay, okay, this is the actual picture of single LED bulb. Okay, any confusion out here? See, these are the same points. Okay, it is used in remote controllers, it is used as traffic signal lamps and solar lamps, it is used as camera flashes, it is used as calculator display, computer screen, TV screen, scrolling advertising display, etc. are also using LEDs nowadays. अहिले हामी टिभी पनि पहिला LCD टिभी भन्छौं, फ्ल्याट टिभी लाई अब LED टिभी भन्छौं है. अनि कम्प्युटरको मोनिटर पनि सुरुमा CRT आएको थियो, त्यसपछि LCD स्क्रिन आयो, अब LED स्क्रिन छ हैन. मोबाइलमा पनि तिम्रो पहिला सुरुमा LCD स्क्रिन वाला मोबाइल आएको थियो हैन, अहिले चाहिँ LED स्क्रिन वाला मोबाइलहरु आउँछ है. Okay, this was for today. Okay, in our tomorrow's class we will discuss about magnetic effect of electricity. Today I want you to prepare note on this topic. Every day I want you to prepare note on the topic we discussed on that day. Okay, this will help you to get better grasp on the knowledge. Okay, thank you class, see you in our next class.